Okay. Thank you all for coming to the workshop on problem solving and critical thinking. I'm Joe Maglioka. I'm a tutor at the at the online ILC. I also tutor some on campus, on South Campus. I do let's see. I tutor mostly chemistry and biology and some math. But today we're going to talk about critical thinking. Basically, what is it, and how it can help with problem solving, both in the classroom and outside of the classroom. So, let's start with what is critical thinking. So, what do you think it means? Feel free to type in the chat or say out loud. What do you think when you see something's a critical thinking problem? What do you think it is? What would that mean to you? Thank you, Starlet. Looking at a problem from a wide and narrow lens, like some multiple perspectives. Is that what you're saying? Yeah, thinking independently. Good, Han. Linda's typing. Anybody else? So yeah, I know I've seen people say that critical thinking question means a hard question. Which in a way, yeah. Is it Usainu Berry says use mindset? That could be that could be I guess kind of use a different mindset. Having to break down a complex problem into bite-sized pieces to come up with an applicable solution. That's part of it, yeah. Getting to the root of the problem might be, yeah. Anybody else? Oh, here's Usainu. Yeah, good point, Usainu. Having a different way to see things. Yeah, looking at it from a different way. Anybody else? Well, let's get moving on. So there are multiple ways to define it, but let's look at some definitions from different dictionary websites. So from Wiktionary, it's defined as the application of logical processes, rigorous standards of evidence, and careful reasoning to the analysis and discussion of claims, beliefs, and issues. Dictionary.com defines it as disciplined thinking that is clear, rational, open-minded, and informed by evidence. The foundation of critical thinking, which says it's a group that tries to promote critical thinking education, defines it as self-guided, self-disciplined thinking, which attempts to reason at the highest level of quality in a fair-minded way. So in general, critical thinking kind of refers to a kind of thinking outside the box, you could kind of say, kind of thinking in a new way, thinking in a way that kind of combines things you've learned from multiple different places. So this is kind of a more big picture. So there's that word again. Big picture definition of critical thinking. How about what does it mean in an academic setting, in a classroom or that kind of, or on campus? So in general, when we're talking about in a classroom, we're talking about and we talk about critical thinking, we're talking about problems and projects that will incorporate multiple concepts and ideas that you kind of have to combine in order to get an answer. So rather than just following like a simple formula or recitation of facts, they kind of require like a combination of methods and strategies and facts you've learned in different places. And you need to combine those in order to solve the problems and complete projects. So if you see a critical thinking problem, they often lead to you seeing a bigger picture perspective of a concept. They can kind of exist on a spectrum ranging from simple, which doesn't require much critical thinking, to a more complex problem that combines a lot of different things. And they're important because they're a lot more like the types of problems you'll face in the real world. They involve, you're not likely to see simple problems with simple answers all the time in real life, but you will see things that require you to incorporate things you've learned in all sorts of different classes and all sorts of different places, really. Let's see here. As for the spectrum thing, again, it's like you could think of as problems get more complex and questions get more complex, you could think of them as requiring more and more critical thinking. So, how do you think critically? Like, what does critically thinking entail? So, there aren't really any formulas, any methods that work 100% of the time when you think critically. Um, you can kind of develop strategies and kind of follow patterns. If you've seen a similar type of problem, you can kind of use that not as like a exact pathway, but kind of as a guide to solving this type of problem. So there are different strategies you might observe depending on the type, and here are a couple following examples. One thing is to ask questions. Don't just read what they're asking you. Kind of ask questions about it. What is it really asking? What is the most important part of this? Also, revisit your questions. Talk about answers to some of the questions, and then go back to some of your answers and see if you need to change your answer depending on what you've decided for other parts. And then revise and update both your questions and answers. Maybe answering one question will help you think of new questions. And maybe you'll come up with an answer to a question, and then later on you'll think about it more and you'll think a different answer would be better. And be prepared for disruptions and wrong conclusions. That is something that a lot of students struggle with when doing this type of problem. A lot of times there's kind of more than one way to solve it, or more than one direction to come at it from, and more than one possibility. So you sometimes have to do some guessing and checking. And I mean, and that can get frustrated if you come up with a way that seems to work and then you find out it doesn't, and you have to throw it out and try to start over from the beginning. So that frustrates a lot of students. It makes a lot of students want to just give up, and that's what we got to. That's what we have to avoid. Um, and always try to separate emotion from reason. Emotion is not necessarily completely bad, but sometimes it can cloud out the facts. So try to focus on try to focus on what is it asking. Don't If it frustrates you, try not to get too caught up in that. So that's kind of vague what I've talked about so far. I talked about, in big picture, what is critical thinking. So I want to talk a little bit more about strategies for critical thinking that apply better to, that apply more specifically to certain types of classes. So let's start with critical thinking in math classes. So math word problems, in a way, can almost always be thought of as a critical thinking strategy. Even the simplest word problems will require more critical thinking than like a simple symbol-based math problem. So, for example, if you have to solve, like, go back to elementary school arithmetic, if you have to solve 3 plus 2 and you enter 5, that's still easier than a word problem where you'd have to do the same thing. Like, John has 3 apples and Mary has 2 apples. How many apples do they have altogether? Already, even that other one requires a little more critical thinking because you have to think what exactly is going on here. You know, and that's whereas if you just write 2 plus 3 equals blank and you write 5, it's really spelled out what mathematical operation you're doing. Of course, a lot of word problems are a lot more complicated than that. A lot of word problems have only one correct solution, um, but some of them have more than one. Sometimes there is sometimes there is only one solution, but there are multiple ways to get that solution. I kind of use it as an analogy. I kind of use the idea of solving a Rubik's cube. If a Rubik's cube is, Rubik's cubes are solved, and then you have to kind of mix them up and then try to solve them back. Get all the colors on one side. Now you could always do the exact opposite of what you did to solve it, but just do the same exact steps backwards. But sometimes you can do other steps in different orders to solve the cube. So it's different. It's essentially one solution, but there are multiple ways to do that, and that's how a lot of critical thinking math problems are set up. And so a good strategy, though, is, like I said, even though you won't be able to just plug problems directly, plug numbers directly into a formula, you can, if you've done enough word problems, kind of come up with like a general pathway you'll use to solve them. It might incorporate formulas. It might incorporate, multiple formulas, that feed into each other. But it's not as simple as just plugging into a formula. But you can come up, though, with like a way. Okay, I recognize this type of problem, so I'm going to have to do this, this, and this. So kind of try to come up with categories of problems. And you'll definitely have some that are kind of you don't quite fit in as well, but that's what we do. They're all kind of like little puzzles, and you just kind of got to figure out what works. So I wanted to give an example problem. And if you haven't taken a math class in a long time, don't panic. The point of this is not to actually solve it, but it's kind of to show the pathway we would go through to set up the method to solve it. So here's a kind of critical thinking algebra word problem. So in a class trip, 400 students go to a museum. Some students pay the regular price of $30, and then some students will get a discount and pay $20. If the trip costs $15,000 altogether, how many students got the discounted price of $20? So what are some steps So we can kind of look at steps. A good place to start is read it and then carefully reread and kind of pick out the most important information. So I read it once, then if we reread it, we see in a class trip 400, there's a number students are going. Some students will pay the regular price of 30, some will pay 20. So some, you'll have two different amounts people are paying. We know the total cost is 15,000 and we want to know how many paid 20 and how many paid 30. So it's the two different totals. So we know. So then we isolate the important information like I did. 400 students, tickets 20, 30 or 20, total is 15,000. And this then kind of write this in mathematical terms that we could potentially use. Well, we have two different amounts paid, so we can call those X and Y. Sorry, my handwriting is always messy. And on this, it's even worse than it is on paper. So if X is the number paying 30, Y is the number paying 20. What do we know? What can we use there? Well, we know the total number is 400. So we know X plus Y equals 400. And we know that the total amount of money collected is 15,000. Excuse me. So 30X plus 20Y equals 15,000. And then, that didn't come out quite where I wanted it. Then we solve using material we learned in class. So if you remember systems of equations, we have two variables and two equations. So we can solve for them. We can solve for the answer. We can solve for the two variables using those. We can use substitution or elimination. And like I said, the purpose of this is not to actually solve it. It's just kind of to look at the thought process we have to take as we go through it. So don't panic. Like I said, it's been a while since you've taken algebra. That's part of the reason we aren't solving it. I changed it to make the numbers look good, and I realized I messed it up. Thank you, Hawk. But yeah, that's part of the reason we aren't actually solving it. Because yeah, it only adds up to 12,000. They have to get negative numbers of students for the others. I knew I shouldn't have changed the numbers. Anyway, but still, even if the numbers worked out to something reasonable, the thought process was the same, would work the same way. And that's what the point of this is, to look at the thought process we'd use. Okay, so that was for a math class. So now let's look at like an English class or a history class or literature class. What would you do? What would critical thinking questions be like there? So a lot of the questions, the kind you'll see on like an essay, will require the critical thinking because they ask you to compare events rather than just like describing events or recounting events. Sometimes they'll be opinion based, ask what you thought of this scene in the book or what you thought this scene means. Sometimes they'll be on something about like the symbolism or whatever they talked about on the talked about in class. A lot of times they ask you to analyze events, either fictional events or or fictional events from a work of literature, or what do you call it, events that happened in history. They might ask you, like, look at the big picture, like either the big picture of the story or a big picture of the history narrative, or to analyze what other people have said about that event or that work, or how other people have interpreted it, and see if you understand why they felt the way they did, see if you agree with them, and so on. So here's an example of a series of history questions that are related, and as we go through, they require more and more critical thinking, more and more critical thinking skills. So, for example, a very simple history question. I chose history because that's a little closer to my area of expertise. What U.S. Civil War battle took place July 1st through 3rd, 1863? Right there, I'm asking for a specific event on a specific date, or 3 specific dates. So that wouldn't require that much critical thinking. That is a recitation of facts. So the answer would be the Battle of Gettysburg. That's like a 1 sentence or less than 1 sentence answer. But a question that's related that requires more critical thinking would be, how did the Battle of Gettysburg affect the course of the Civil War? That requires at least a paragraph and requires incorporating some other events, other historical events. So see, you're kind of putting them together to talk about a bigger idea rather than what happened. Saying what happened, you're saying, what did it mean? And then that requires, like I said, at least a paragraph. But then you could have even more complicated questions, one that would require like an essay to answer. And this requires even more critical thinking. So like the Battle of Gettysburg, so my thing here is the Battle of Gettysburg is often said to be the turning point of the Civil War. But less than 2 weeks after the Battle of Gettysburg, the New York City draft riots occurred. And as a year later, President Abraham Lincoln seriously feared losing the 1864 presidential election. So given that it's commonly stated that it was a turning point, and given evidence that it wasn't really a turning point, I'm asking, do you agree? And why or why not? So that kind of answer requires a lot of critical thinking and a lot of incorporating a lot of different events and a lot of different analyses of the war. And so it is kind of opinion based. There isn't really a wrong answer. But it's the kind of question they ask to see if you really understood what they've talked about in class. You have to take lots of evidence from lots of different perspectives, as well as lots of different events. So like I said, that would require an essay. And so that, an essay, multiple paragraphs. So that would require even more critical thinking. So you can kind of see, you might get questions, and the same thing could be said for like an important event in a novel or some other work of literature. And so that requires more critical thinking than there's different levels of critical thinking, and they can kind of build up depending on level of the the level of in-depth the class or the instructor wants to go. And now let's talk a little bit about critical thinking in science classes. So science problems and questions almost always build on previous knowledge, so they kind of require critical thinking by their nature. But of course, some are still more simple and straightforward than others. And of course, depending on what discipline of science we're talking about, that can make a big difference over how we approach their problems and stuff. So like there's different levels of math involved in different sciences. So like physics is pretty much all math. Biology has very little math. And then chemistry is kind of in the middle. It's probably more math than not, I would say, but it isn't all math, so it depends. Depends on what exactly you're talking about in that class. But again, like math problems, the simpler science problems often involve just either describing facts or simply plugging into a formula. But a more critical thinking problem will involve combining multiple techniques and multiple formulas and or describing multiple events from different perspectives. So in general, this is definitely true for critical thinking in science. Um, the they almost always kind of have require that you take little bits of facts and combine them to make a combine them to look at to help you see a big picture perspective better. So I'll give an example again of a science question. I decided to do a biology based question because this is, I'm technically a biology tutor. I'm officially a biology tutor, even though I also tutor some other subjects. So again, these require different levels of critical thinking. The later questions, though, kind of build on the previous ones. But if you look at the first question, what are the properties that define something as living? So that if you've taken a biology class, you've learned there's a list of properties that define something as living have. They can regulate their environment, they have metabolism, they can respond to stimuli, they can grow and reproduce, that kind of thing. So this question is just kind of asking you to list those properties. Um, this next question, though, asks, what is an example of a non-living thing that has one of each of those properties that define life? So many of those life-defining properties can still be seen in other things. Things that most people or everyone would agree are non-living. They still can do some of one or more of those they have one or more of those properties that would define it as living, but they don't have them all. So that's the example. It's trying to show you why it's important to define life that way and help get away from the whole "I'll know it when I see it" type definition of life. And another question, this would require more writing or more, a longer answer that takes more information into account. But it might ask that why viruses are often said to be on the edge of living and non-living. They're really kind of the closest thing to we don't know whether they're living or not. And so why, you can ask, it's like why and what properties of life do they share? What properties do they lack? So it's kind of opinion based of sorts. There's some opinion, but it wants you to use the real evidence. So again, it requires a longer answer and a more critical thinking perspective. Okay. So looking at all these different critical thinking questions and different and problems in a a classroom setting, how do these come together to prepare us for critical thinking in real life? Well, it's because most of the problems you'll encounter in real life are going to require critical thinking skills. Because real life is not divided into subjects and classes so neatly as it is in school. So if you run into a real big problem, you're probably going to have to draw on your knowledge that you learned in a lot of different places, lots of different subjects and lots of different classes, and out of classes. You have to incorporate all sorts of knowledge in real life. And keep in mind that even the critical thinking activities in the classroom are still going to be simpler than most real life situations. The real life situations often will have multiple quote unquote correct solutions, or they might not have a correct solution at all. Basically, sometimes when there's a problem, there's no really good solution. There's only like finding the least bad solution. And so that's why we have to think about these. So now I wanted to do a little activity involving critical thinking in practicing for critical thinking in real life. So far, we've talked about critical thinking in particular classes, but all of you are in different classes. You've taken different classes. It's been longer. It's been more or less time since you've taken things. So I wanted to focus on something that doesn't really directly relate to material you've learned in school at some point, but you probably learned some of this in school. Some of it you may have learned in other places. I wanted to come up with this. So I wanted to do this activity kind of as a run through to try to use critical thinking and use critical thinking and see how it might be useful in real life. So for the activity, imagine that we're in a classroom and we're filling a box with emergency supplies for a classroom. I'm kind of expecting a box bigger than what we see here in this little picture. And so it could be a lot bigger even. I won't be strict with the size of the box, just nothing ridiculously large. It has to be something, what we put in there has to fit into a classroom and be reasonably accessible to those that are in the classroom. So think of all the emergency situations we could possibly encounter in a classroom. And we want to be as prepared as possible for those situations. Knowing that, what would you put into the box? So it doesn't have to I know this kind of primes you to think about medical supplies, which we do want that. But what else? Not just medical supplies. Thank you, Starlet. A cell phone, that's interesting. Yeah. Oh, yeah, non-smartphone even. Yeah, one that's simple and doesn't require Wi-Fi or anything. Evacuation plan, good. Anything else? In my earlier session, it's like only thing anybody chose was medical related, and here nobody, no one so far has chose medical related things. But so remember, medical or not medical. A couple people are typing now. Band-aids, good. Enhanced sanitizer, good. Yep. AED, matches. Said band-aids or bandages. I'll say bandages. Defibrillator. Oh yeah, defibrillator. Yep. Oh great, yeah. Canned food, aspirin. Good. Water. Alcohol wipes. Blanket. Good. Ugh, sorry, my handwriting's so bad, and it shows up even worse here. Water, alcohol wipes. Anybody else have any other ideas? Ashley, thank you. Salt, yeah. Ashley's typing, so. Door stop, zip tie center base of door. Yeah. Flashlight, good. I was hoping somebody would say that. Flashlight. Linda's typing. Excuse me. Batteries for flashlight, candles, good. Anything else? This is a good mixture of things. I have a couple ideas, but I know what the emergency situations I came up with are, so I don't think it would be fair. I'll mention them later. Oh, Linda's typing something else. Emergency numbers, good. Oh, good. You guys hammer. Yep. Sorry, didn't show up well as I wanted. Okay, I think we got a lot. This group got into it a lot more than my previous session, so that's good. Okay. Let's go on now to some emergency situations. So let's discuss some of these emergency situations and how your items might be useful. So I'll say a little content warning. However, there won't be any active shooter lockdown situations that are discussed. Okay, so scenario one. So the fire alarm goes off. We're in class. The fire alarm goes off. We prepare to leave, but we smell smoke immediately and we see smoke and fire in the hallway. So I'll go back to our list of things. Which of these would be useful in this situation? If it's a fire and it's a fire in our hallway. Wet towel. Oh, yeah, if we had those, I guess, maybe. Blanket, yep, stuff for the base door, great. Cell phone, call 911, just to make sure we shouldn't assume anyone else is called. What if everybody assumes everyone else is called? Great. Blanket evacuation plan. So that might tell us we have to go out the window. Hopefully we're not on the second floor or third floor. Anything else? Well, if we have to get out the window, maybe we could use the hammer. We might have to use the hammer, and if we have to use the hammer, if people squeeze through. Yeah, wet towel. Oh yeah, that could help. Especially, yeah, put under the door. That could help slow the fire down getting inside. So that's good. If we had to break the window to get out, we might need band-aids. So that's good that we have that. Hopefully we're not on the second floor, like I said. Other than that, we're gonna definitely need band-aids. One thing I thought of that I've seen these before, they're like little ladders you can keep by the window in case you have to climb down out of them. That might be a good thing to put it in the first place, especially if we're on the second floor or third floor or something. That could help you climb down. Oh, yep, that's too. Yeah, that's great. Yeah, another good point, Starlet. Yeah, cut it up. If we don't have the ladder, we can also use the blanket to make it. That's great. Great point. This typing. You guys have gotten a lot more into this than my previous session, so even though there's fewer of you, so that's good. Oh yeah, that might work as a mask. Okay, well, why don't we move on to the next situation? So, in the middle of a class, a student begins to appear sick, and suddenly she collapses at her desk. Another student says she might be diabetic, like they think they heard her say that at some point. And we notice there's a glucometer in her desk. So, what can we do in this case? Glucose tablets, yes. And if we don't have those, what did we put in there that we could use? But yeah, glucose tablets were going to be one of the things I would suggested. Yep, cell phone 911, blanket to help transfer her. Yep. We do have something that could help her, though, even in the absence of glucose tablets. Canned food, yes. Especially if it has a decent amount of sugar. You got it, Linda and Susan. Canned food. I've seen people also like putting crackers, especially like peanut butter crackers. Those are kind of good. We actually had a student go into insulin shock once when I was on South Campus, or she started to. I don't think she actually went into shock because she was always conscious. And we gave her yogurt really quick that had sugar in it, and that did help her get better. But yeah, we should probably still call 911 depending on how bad it is. I know I've seen students. Once I had a student recently who had a seizure. Oh yeah, yep, that's good. Yep, ketchup or chocolate works too. That's a good thing. We had a student who had a seizure, and I was kind of like, "Oh my god, are you okay?" And she was like, "Oh, it happens all the time. Don't worry about it." And then she was fine. So, but yes, yeah, chocolate and ketchup. Yep, those are all good things. Okay, let's go on to our next situation scenario. All right. So it's one stormy afternoon. We all receive a text from the school's emergency notification system. And it says that the area is under a tornado warning. And immediately after we receive that message, the power goes out. What can we do and how can we use them? Flashlight, definitely, first thing. Evacuation plan, yep, they have leaving the building plans, and they often have like a plan for a safe room in the event of a tornado or something. Anything else? Yeah, we want to get out of the room. The flashlight, candles, batteries. Let's see. Maybe bring the hammer and blanket with us in case we need to get into like you have to hammer to get out and we have to get into a uncomfortable place. The blanket might make it a little more comfortable. Is there anything else we could use? I guess bring water and food just in case we're stuck there for a while. Yeah, first aid supplies in case someone is gets hurt or is already hurt. This was another thing I thought of, is a radio, especially, if the Wi-Fi is going to be out, and maybe the cell phone towers are out. Although if they're out, the radio's probably out too. Um, but a little like battery powered radio or a hand cranked radio, if you've ever seen those. That would probably be useful because it would, in case, like, you might put a battery operated radio in, but by the time we actually need it, the batteries might have died. I mean, they might be dead. And so, yeah, but actually, yeah, I did too. That's where I got the idea. Oh, yeah, and yeah, electricity generators are still pretty big, but maybe if there's one already on campus, that's one place we could go and try to turn on, depending on situations. Okay, good. Walkie talkies. Oh, yeah, that would have been a good one. And we said bring the first aid supply. Linda, I didn't. Yep. All right. And ready for our final one. This is the one I put the content warning on. So during a chemistry lab, a student breaks a piece of glassware in his hands, which definitely happens more than you might think. And a fragment of the glass makes a large cut in his thumb. And we see he's bleeding quite a bit. So what are we going to do here? Hand sanitizer, great. Duct tape. Oh, the duct tape would have been good. Yeah. We talk about alcohol wipes. If we have hydrogen peroxide or triple antibiotic ointment, those would all be good. Tourniquet, depending on how much he's bleeding. But yeah, we might have to. We might just be able to use the band-aids. Find out if he's, has hemophilia or something. Super glue. Oh yeah, that's good if we needed to. Aspirin might be needed. Yeah, depending on how much it hurts. We probably still have to seek medical attention. Maybe not, depending on how much it's bleeding. 911, or if not 911, at least go to an urgent care. Yeah, pressing on the wound with cloth can get the bleeding to stop, and raising his thumb over his head. Um, let's see here. Blanket can help, cover it. That could make a tourniquet if we needed that. It could also just kind of help, help prevent blood from getting everywhere. We don't have gloves on here, but that would definitely be useful. Um, what else might be useful? We should probably still seek medical attention because there might be a little piece of broken glass in the cut. And so they would need to do an x-ray. That's really not an emergency if he's not bleeding too much, but it is something they're going to have to take out. Anything else? No, going once, going twice. Okay, well, we used up pretty much just the right amount of time anyway, so I guess that is all for our little activity. Oh, so are there any questions before we go? Starlet's asking something. Oh, great activity, thanks. And thank you all for participating. And thank you all for coming. I hope this helps you with the concept of critical thinking somewhat. Let's see here. Anything else? You're all welcome. And so I hope you learned a lot today in this lecture, in this workshop, and in your other ones. And I think this is the last one for the day, so we don't need links for the next lecture, the next workshops. So, well, I mean, you have the oh yeah, the closing keynote. I forgot about that. Oh, no, wait, we do have the 4:30 ones. So just a minute. Let me send the links for your 4:30 sessions, and I will let you go on. And so once I stop the recording of this meeting should show up within a few minutes. But here, whichever of these you're taking, um, you can click the link to get on to the next one. All right. Well, thank you all again for coming. Good luck with all your classes in the future. And we will see you around. Let me stop recording.